Hello, thank you for introduction. And in this short talk, I would like to introduce you GRIX, which is a tool we've developed in a small team at Creative Doc, let's say in the last half a year. And why? Because we were rather unsatisfied with the possibilities of RAG's retrieval-augmented generation. So retrieval-augmented generation is a way how to give large language models a possibility to access the knowledge they haven't seen during the training. So it's a novel or proprietary knowledge which we want to get answers for our questions. And the problems there are like very tough. It concerns if we have a large knowledge base, a lot of documents, it complicates the performance of classical RAGs. As well, the complex questions are difficult to address. And the thing is that having a complex question, you need somehow integrate the knowledge throughout the whole knowledge base. But if, for example, the knowledge is scattered throughout the knowledge base, then it's difficult for classical RAG to collect it and put it together. So in these two mentioned related works, again, they were published this year. HypoRAG is focusing on multi-hop questions. This means these are questions which require answers gathering the knowledge scattered throughout your knowledge base. And the second related thing is tool is GraphRAG, and they focus on so-called global questions. Imagine you have a question not really aiming at one particular thing, particular entity, whatever, but you are asking question like what are the main topics covered by my knowledge base. So these type of questions are really difficult to answer by classical RAG. And this short talk will be about what we can do about this. So GRIX is a shortcut of graph index, and it's our tool how to address problems I've sketched right now. It consists of three parts. I will go into the detail later, but right now, let's say that at the beginning, you need to transform your corpus of documents, your knowledge base, into some structured form. And we choose graph form. So provided we have a graph, then we need to be able to retrieve information from it, and which information to retrieve, or more precisely, how to retrieve, often depends on the type of question. So at the beginning, I've mentioned two types of questions, multi-hop and global. So for each of these types, you need a different approach how to make the answer. So the three parts of GRIX of our RAG are extraction, retrieval, and then generation of the answer itself. The generation is least interesting part, because it's just assuming we have we retrieved all relevant knowledge to the question. Generation is just about wording using the large language model to give you the proper or nice answer. But in detail, I would like to discuss two former parts, extraction and retrieval. During extraction, you structure your information and create the graph, the knowledge graph. You can imagine that the structure of information is as stated here. You have you can define entities, entity types. For example, you can have a person which has a name and then several relationships to other entities. For example, a person is employed by somebody. It has several other relationships to another entities. We use more attributes for each entity, entity to be extracted. One of the most important ones are description, which is like short paragraph introducing the entity, and keywords. Keywords are later used to search through our knowledge graph and to create to create some, let's say, summaries, in sense that you can group the persons, or not persons, the entities in general, with similar keywords, with similar interests, let's say. The second part is retrieval. So provided you have a structured knowledge, then you need to get the relevant knowledge only. So I said more about extraction, so maybe make this shorter. So at the beginning you have a schema. Imagine the person and their or the person attributes. We use large language model to fill this schema, and this is our structured knowledge. Then we need somehow to modify it to just correct some errors arising during the extraction part, and then we construct the graph in Neo4j using Cypher queries. It may happen that some nodes are representing the entities, and edges are just the relationships between them. So it may happen that nodes are duplicated because you are like extracting each file. You are extracting file by file. So you can duplicate nodes. The question is whether this is bad or not. For example, for global questions, when you are doing summaries, it doesn't matter really if you have duplicated nodes or not. But in some another scenarios, it may complicate your retrieval part. So we distinguish several types of nodes, and we work with these types of nodes differently. So for example, we have a special nodes for document itself, then for the data collected from the documents, and then we have nodes for keywords, which we treat again in different way. The retrieval, you can see the retrieval as a sequence of steps. Here you have a classification of steps into 4 categories, and you can use multiple. You can use them multiple times during your retrieval pipeline. So imagine you have at the beginning you are retrieving the information, so you search for the most prominent, for most relevant nodes in your graph, or depending on the type of the question, you want to make summaries from distinct subgraphs, let's say. Then you would like to re-rank these nodes you have found in the search phase, and maybe you would like to expand the these nodes. For example, you can take a neighborhood, or you can search for shortest path connecting the nodes. So these are the main steps appearing in retrieval. And to this point, Neo4j and especially GDS library can be really helpful. So, for example, it can be used for ranking of nodes using different types of ranks or centralities. And for summaries, you can use Leuven or Leiden algorithm. You can search for shortest paths or construct the neighborhoods, as I mentioned when describing the retrieval. So this is just an example how the GRIX looks right now, and this is a short video of the knowledge graph. So, okay, we have some time, not so much, but this is just 40 seconds. So by color, we distinguish, the color distinguishes the different types of nodes. The bigger circles, red circles, are nodes representing documents, and the rest are nodes of different type. So, for example, the blue can be person, etc. Okay, so once you have a graph, you are able to retrieve the information. The question is how to evaluate whether you extract properly, whether you create the graph properly, and whether your retrieval is good enough. The basic problem, or the problem here, is that we lack any labeled data, any state of art labeled the database. So for extraction, we use idea coming from needle in haystack. You can imagine that you introduce a piece of new, unique information, the needle, into your document. And then you just examine whether the needle, this piece of information, was extracted correctly or not. This is described in our paper, Assessing the Quality of Information Extraction, in more detail. The same approach, or the same inspiration by needle in a haystack, can be used for retrieval, for evaluating the retrieval part. Now you can the needle can be the node. You can add a new artificial node into your graph and examine whether it can be, or the information contained in this node can be retrieved or not. Another option is Ragas tool. It's widely used to evaluate large language model applications. It allows especially generating synthetic ground truth question-answer pairs, which is very useful if you don't have such ground truth. And then you have several metrics how to measure performance of your retrieval or generator. The final option here, you are completely missing the ground truth. This is the case, for example, especially for global questions, because it's very difficult to construct ground truth question-answer pairs, even if you are aware what is in your knowledge base. So head-to-head comparison is just you compare outputs from, let's say, two models and just deciding which one is better. Here is the list of references, and I would like to mention the team. So these people were really important for the GRIX building. And thank you for attention.